Today, we are looking at the determination of saponification value. We'll start by looking at the definition of saponification value. Saponification value is defined as the number in milligrams of potassium hydroxide required to saponify completely 1 gram of fat or oil. The saponification value is expressed as the number of milligrams of potassium hydroxide required to saponify a gram of fat. So that's milligrams of potassium hydroxide required to saponify a gram of fat. This method is used to determine the total acid content. That's both the free and bound fatty acids in lipids. Let's look at some key tips. First of all, what we have to notice that saponification is influenced by the composition of the fat or oil. And 2, long fatty acid or those with a higher molecular weight and longer carbon chains tend to have lower saponification values. And this is because longer fatty acids have a lower ratio of reactive functional groups. That's the carboxylic acid group to the overall molecular weight. Or in other words, long fatty acids have more carbon atoms in their chains, which means there are fewer carboxylic groups relative to the overall size of the molecule. And since it's the carboxylic acid group that reacts in the saponification process, a higher molecular weight fatty acid with fewer carboxylic acid groups relative to the overall size of the molecule will need a small amount of alkali to saponify, hence resulting in a lower saponification value. In contrast, fats containing short-chain fatty acid will have more carboxylic groups per gram than long-chain fatty acid, and hence will react with more alkali to produce a higher saponification value. For example, if the saponification value of fat is 270 milligrams of potassium hydroxide per gram, what it means is that 270 milligrams of potassium hydroxide is needed to saponify all the fatty acid. That's both free and bound fatty acid in 1 gram of the fat. Let us look at factors affecting saponification. So first is the ethanolic potassium hydroxide or ethanolic sodium hydroxide. Second is the reaction time, and the third factor is the reaction temperature. So these are the 3 basic factors that affect saponification. Significance of saponification value. 1. Saponification value gives an idea of the molecular weight of the fat or oil. And what we have to note is that the smaller the saponification value, the higher the molecular weight. 2. Saponification value indicates the length of the fatty acid in the fat or oil. Thus, the higher the saponification value, the greater the percentage of short-chain fatty acid present in the triglyceride. 4. Saponification value indicates the mass of alkali required to saponify oil or fat. And the last, saponification value determines the quality of fat and oil for soap production. Let's look at the materials that we are going to use to perform our saponification experiment. So we have the fat and oil, we have our fat solvent, which happens to be equal volumes of 95% ethanol and ether. We have alcoholic potassium hydroxide of this concentration. We have a reflux condensers, boiling water bath, phenolphthalein of this concentration, hydrochloric acid of this concentration, burette, and conical flask. So these are the materials and the reagents that we are going to use to perform our experiment. So the first method, step 1, accurately weigh 1 gram of fat into a third round bottom feed flask. Add about 6 ml of the fat solvent and mix to dissolve. 3. Add 25 ml of the 0.5 molar alcoholic potassium hydroxide and attach to a reflux condenser. Set up another reflux condenser as a blank with everything present except the oil, and heat both flasks on a boiling water bath for 30 minutes. So this is the setup for the reflux condenser over here. So this is our water inlet and this is our water outlet, and this is our round bottom flask containing our test sample on a water bath. For leave to cool to room temperature and titrate with 0.5 molar HCl using a phenolphthalein indicator. So what we have to note is that the difference between the blank and test readings gives the number of mils of potassium hydroxide required to saponify a gram of fat. And from this equation, we have HCl reacting with potassium hydroxide to give us potassium chloride with water molecule. So what you can also see from the equation is that the mole ratio between the potassium hydroxide and the HCl is the same, that is 1:1. And since the concentration of the HCl and potassium hydroxide used is the same, then it means the volume of potassium hydroxide in mils needed to neutralize the fat or oil is the same as the volume of HCl used in the titration. And the formula to determine the saponification value is given as this. So where B happens to be the volume in mils of HCl used in the blank titration, and S happens to be the volume of mils of HCl used in the sample titration. The W is the weight of sample in grams. The N is the normality of the standard potassium hydroxide solution. And the 56.1 is the molecular weight of potassium hydroxide. And what you also have to note is that the unit of saponification value is expressed in milligrams of potassium hydroxide per gram. So this is an assumed table for our result. So this is the burette reading, and this is our control reading. So this is our lipids here. So the first is the vegetable oil. We also have the soya beans oil, the olive oil, and the extracted lipids. So from here we can see that the titer value for the control is 26.70. For that of the vegetable oil is 20.20. That of the soya beans oil is 21.0. That of the olive oil is 19.7. That of the extracted lipid is 20.0. Now, from the table, And using the formula for the saponification value, we will calculate for the saponification value for each of the lipids used. So the first is the vegetable oil saponification value. Now, from the table, this is the moles of our blank, which is 26.7, and this is for the vegetable oil. So times the 0.5, which is the normality of the potassium hydroxide, times 56.1, which is the molecular weight of potassium hydroxide, divided by the mass in grams of lipid used for the test analysis. So if you are to do a calculation, we will have a saponification value of 182.325 milligrams of potassium hydroxide per gram for our vegetable oil. For the soya beans oil, if you are to substitute the results into the equations over here, we will get a saponification value of 159.885 milligrams of potassium hydroxide per gram as a saponification value for the soya beans oil. For the olive oil saponification value, if you are to substitute, or if you are to put in our values or our result into the equation, we will get a saponification value of 196.35 milligrams of potassium hydroxide per gram. For the extracted lipid, we are getting a saponification value of 187.935 milligrams of potassium hydroxide per gram. Let us now look at the difference between acid value and saponification value. So this is acid value, saponification value. So in terms of definition, acid value is the number in milligrams of potassium hydroxide required to neutralize the free fatty acids in 1 gram of fat, while the saponification value is the number in milligrams of potassium hydroxide required to saponify 1 gram of fat. So in terms of measurement, the acid value measures the amount of acidity, whilst the saponification value measures the amount of ester linkages. In terms of method, the acid value involves the direct titration with potassium hydroxide, whilst the saponification value method involves back titration with potassium hydroxide. Thank you.